Okay, so now that we've got a bit of a handle on the connection between the typical transformation parameters that we know and love and their connection to these particular terms, these more technical terms that are unique to trigonometry, specifically sinusoidal functions, um, let's actually look at them. So, amplitude, for example, we have a definition of amplitude here, and it's simply the vertical expansion. Hopefully, this isn't too surprising. It's the vertical expansion or compression for trig functions. Right, we had made that connection in the previous video that the a parameter, which is the parameter that controls vertical expansion and compression, as well as reflections technically, in the x-axis. But if we're only interested in its absolute value, then we can call that also the amplitude of the sinusoidal function. So like for example, if you look at the graph of a sinusoidal function, cosine, by the way, is also a sinusoidal function. Let's say this is just y equals sine of x. We know the maximum and the minimum are just 1 and negative 1. And so the amplitude, we could say, is really, well, here we know that the a value is equal to 1. So the absolute value of a is also equal to 1, right? Because there's no coefficient explicitly written, so the number in front is really just 1. And we could also say that the amplitude is really just the distance between this center line point and either a maximum or a minimum. It's up to you. They'll be equivalent. So here, what we would call this is the amplitude. This is also the amplitude. It's really just the distance, again, between the center line, right? This middle line that cuts the wave in half, and either a maximum or a minimum. Doesn't really matter. They will be identical distances. So that's what the amplitude is. It's really the size of the wave vertically. For example, if this were a sound wave, so let's actually look at a wave with a different amplitude. So this is a wave with a different amplitude, a higher amplitude. So we can clearly see, let's say 1 is still right here, and maybe this is 2. What would the amplitude of this particular sine graph be? Well, the amplitude would be 2, right? The distance between this center line point and the maximum is 2. The distance between the center line point and the minimum is also 2. So that's what the amplitude is. And so if both of these sine graphs were modeling some sort of sound or something, then the one on the right would be louder. Amplitude corresponds to a whole bunch of different things. Also, like if you are in the ocean, you would likely prefer waves like this. You would likely prefer waves with a lower amplitude unless you're like a professional surfer. If you're a professional surfer, maybe you would prefer waves like this because you would be able to, I don't know, have more fun on it or break a record or something. Okay, so examples. State the amplitude of each of these following functions. Well, the amplitude is really just the number out in front, this factor out in front. So here the amplitude is 1/2. Here the amplitude is just the number in front, which is 7. Here the amplitude is just the absolute value of this a value, which is just the absolute value of -1, which is just -1. So the amplitude, sorry, the absolute value, pardon me, the absolute value of -1 is just 1. So sorry for that confusion. Absolute value function, all that does is really just force the number to be positive. If it's 0, it just leaves it alone. So here we notice even if there's a negative in front of the sine term, it doesn't change the size of the wave. So this would be, for example, this would be y equals negative sine x. We'll see that the amplitude is the same, negative sine x. So here we have negative sine x, so we see this reflection, right? But here, this minimum would still occur at -1, and here, this maximum would still occur at +1. So the amplitude is really the same, right? The distance between the centerline point and the minimum, or the distance between the centerline and the maximum, are still the same. So there you go. And then here, what is the amplitude for this cosine function? Well, the amplitude is just going to be the absolute value of -4, which is just +4. And here, we technically don't speak of tangent as having an amplitude, so let's just get rid of that. Tangent function looks something like this, but then it just does that again. And we've got asymptotes as well, which I won't bother drawing. And so we can see there's no real distance between the centerline point and a maximum, or the centerline point and a minimum, because there is no maximum and there is no minimum. They just increase and decrease forever. So there's no amplitude for tangent functions. All right, so here I want to determine the amplitude of this function that we've been given the graph of without coordinate axes or a grid or anything, so we've got to do some problem solving. Well, here, if the maximum is 8 and the minimum is -8, then the center line must be in between +8 and -8. What's exactly in between +8 and -8? 0. Another way to figure that out is to add the numbers together, 8 plus -8, and divide by 2, or in other words, taking their average, their arithmetic mean. That would just be 0. So we know that the centerline point is at 0. We know to call that centerline point the vertical displacement, right? This will move up or down depending on the d value. So we could say d is 0 here, but it says, might as well. D is 0 for this particular graph. So here, the distance between 0 and this maximum, what is the difference between 0 and +8? Well, the distance is 8. What is the distance between 0 and -8? Well, -8. What if direction doesn't matter and we're forced to take the absolute value of it? Well, +8 then. So here, the amplitude of this particular function, just the distance between the centerline point and the minimum, or the distance between the centerline point and the maximum, is really just 8. So that's the answer to that particular question for amplitude. All right, so that's all amplitude is. It just shows us the vertical stretch. What about period? Well, hey, let's just do that in the next video. Let's take a little bit of a break here.